Bridging the Divide, the Future of Medical Evidence. Welcome. If you look at the history of modern medicine, our quest has always been for truth. We want to know unequivocally if a treatment works. For decades, we have relied on a single, powerful tool to tell us that truth, the Randomized Controlled Trial, or RCT. It is, as we often say, the gold standard. But today, we're going to challenge the idea that the gold standard is enough. We're going to look at a new paradigm, one that bridges the gap between the sterile lab environment you see on the left of this slide and the messy reality of the hospital hallway on the right. We're talking about real-world evidence, or RWE, and how it unlocks the hidden potential of data like electronic medical records, or EMR. Our goal today is to move away from viewing these two methods as competitors. Instead, we will explore how they form a synergy that creates a comprehensive medical picture. Let's start by auditing the incumbent, the RCT. RCTs are designed for high reliability. They isolate variables to prove efficacy, answering the specific question, can this drug work? However, as this slide illustrates, this reliability comes at a hidden cost. To achieve that perfect scientific isolation, RCTs create an artificial setting. They select a homogeneous study group, the blue figures in the center, and apply strict inclusion and exclusion criteria. This creates the bias of exclusion. By filtering out the complexities of real patients, those diverse figures on the outside with comorbidities, different ages, or different lifestyles, RCTs produce results that are difficult to apply to the diversified situations of the real world. This brings us to the challenger, real-world evidence. First, we must distinguish between the data and the evidence. As you can see in the funnel here, we start with real-world data at the top. This flows from daily life, glucometers, health apps, insurance claims, and health surveys. But the most definitive source is the EMR at the bottom, which holds diagnoses and prescriptions. When we analyze this raw data to derive clinical insights, that is real-world evidence. It is vital to understand that real-world evidence is not just a looser version of an RCT. It is structurally the polar opposite. Purpose, where RCTs prove efficacy, RWE proves effectiveness. Does it work in practice? Setting, RCTs use an experimental setting, RWE uses a real-world setting. Treatment, RCTs use fixed patterns, RWE observes variable patterns. Population, RCTs require homogeneous groups, RWE embraces heterogeneous populations. And perhaps most attractively for researchers, RWE is generally lower cost and shorter in duration. Now, you might ask, if RWE is so practical, why isn't it the gold standard? The answer lies in the messiness of the real world. The first major hurdle is data quality. As shown here, dirty data is full of errors or missing text. This creates the bias of dropout. If we're missing baseline data like height or weight, we might have to exclude those patients, which reintroduces bias. The fix? We need massive sample sizes to offset the data we lose during cleaning, and we must implement the meticulous data quality management process you see in the center funnel to ensure we end up with clean data. The second hurdle is the compliance gap. In an RCT, we watch patients take the pill. In the real world, EMR data tells us what was prescribed, the hand on the left, but not necessarily what was taken, the bottle on the right. We often have to use workarounds like calculating compliance based on prescription refills. Because of this variable, RWE struggles to prove strict causal relationships the way RCTs can. Finally, we must navigate privacy and ethics. However, this is actually a regulatory advantage for RWE. Because the data is retrospective and anonymized through de-identification, removing names and IDs, and encryption, informed consent is generally not required. This streamlines the research process significantly compared to prospective trials. So how do we use this strategically? The most powerful insight is that RWE can be used to de-risk RCTs. Follow the flow on this slide. You start with an RWE pilot study on the left. If the study shows promising signals, the blue path, you refine your RCT design to target the right patients. If the study detects poor outcomes, the red path, you avoid a failed RCT entirely. This offers immense strategic value by mitigating the risk of the enormous consequences associated with failed trials. Ultimately, we're looking at a mutually supplementary relationship. It's a cycle. 1. RCTs establish efficacy. Can it work? 2. The treatment moves to validation in practice. 3. RWE establishes effectiveness. Does it work in real life? 4. RWE generates new hypotheses and safety signals which feed back into future RCTs. To wrap up, if you're planning RWE research, follow this checklist. Define clear inclusion and exclusion criteria. Secure large sample sizes, implement strict DQM protocols, and ensure total de-identification. As we conclude, remember the quote on our final slide. RWE does not need to mimic RCTs to be reliable. It must be judged by its own standards of rigor. When we discern the advantages of each, we bridge the divide and create the most powerful evidence-based research method in medicine. Thank you.